All right. Well, howdy, everybody. It looks like there's a few people trickling in. I think we can go ahead and get started. If you have questions for me today, as we're talking about data reliability engineering, please drop them in the chat here, and I'll take a look at those. We also have a few surveys that I will bring up during the talk, so please keep an eye out for those. But without further ado, I'm going to go ahead and share my screen. And today we're going to talk about data reliability engineering, what that is, and why that's important for data platform teams and how they are going to use data reliability engineering to strike a balance between velocity and reliability. So without that, let me go ahead and share my screen here. Okay, so let's see. Hopefully everyone can see the slides. So data reliability engineering, balancing speed and reliability for data platform teams is my talk today. So first off, who am I? So I'll introduce myself. We're going to talk about what the challenge is that data platform teams face around this balance between velocity and reliability. We'll talk about data reliability engineering and how that is going to assist with that balance, and then we'll talk about why now. This is a 30-minute session. I tend to talk pretty quickly, so we'll should wrap up before the 30 minutes, and then it's a great time to take any questions. But please drop those in the chat if you have them throughout. So who am I? I'm Kyle Kirwan. I'm the founder and CEO at Bigeye. Bigeye is a data observability company. We'll talk a little bit more about our viewpoint on observability, but you guys are obviously here to dig into the observability space, so I won't talk about that too much. You've seen plenty of that today. Prior to starting Bigeye, I was at Uber for about 6 years. So I joined as one of the first people working on data there. I was a data scientist originally, so I helped start their experimentation platform team. So if you were to open Uber in any major city, so LA, New York, Chicago, Boston, Seattle, pick one. When you open the application, you're probably experiencing 200 to 300 concurrent A/B tests that you are a participant in. So that's a result of the experimentation platform team and the tooling that we built to allow Uber to run and analyze outcomes from all of those experiments. So they experiment in the product, their pricing system, ETAs, their support management system, all sorts of things. After that, I became a product manager in their data platform team. In particular, in addition to operating all of its own data centers and data infrastructure, so having one of the largest data lakes in the world at around 200 petabytes, 100 petabytes and 100,000 or so data sets, as well as one of the world's largest Kafka installations. They also built all of their own tooling for doing things like business intelligence, writing queries, creating dashboards. There was open access throughout the company to make changes to the ETL system, add and create your own tables. Anybody could add data to the lake as well as consume it out. So very self-service environment. We're going to talk about that a bit more in a moment. But one of the big challenges we faced there was how to operate all of that. Who owns what data? Where's it coming from? Where's it going? Is it fresh? Is it high quality? Is there data that maybe we need to sunset because it's not useful anymore? Things like that. So my team was about 15 folks, and we built tools like a data catalog, data lineage system, data quality testing to support that. And then I left the company in 2018 to start Bigeye in the data observability space based on how critical I saw data observability to the success of the data platform team to Uber as it grew. So let's talk about the challenge first. So what is the challenge that necessitates this idea of data reliability engineering? So the challenge, maybe many of you have seen this at your organizations, is that we have, here on the left, we have the market, we have our customers, we have revenue that we're trying to generate for our business. The way that we do that is by selling some sort of a product, right? So the product teams that build that product that our company uses to make money, they emit data back into our data platform. So that's in the form of logs, database snapshots, what have you. They're also often consumers of that data back out, right? So they want to run tests on the product. They want to, look at KPIs about the performance of their product. So they're consumers of the data platform in addition to producers. And they're using that information from the data platform to make better decisions and to drive revenue. But they're not the only ones using the data that they produce, right? So they emit data into the data platform, and then it's used by a whole bunch of other people as well, right? So we have people in marketing that might be consuming information about product usage. The finance team needs to know, units sold and things like that. If we have a growth team, if we have a security team. So all of these different stakeholders around the company are consuming the data that's produced by, maybe our product teams or our services teams. So time for a survey. I would love to know at your organization, what degree do you feel that all these different teams around the business do indeed have self-service access to that data on the platform? So is it very, sort of locked down and we have a very centralized and controlled data team and they really provide data to the organization as a service, or are we talking about self-service open access? Any of these teams, the finance team, growth, accounting, whoever, do they all have access to the data platform? Are they building their own analytics products on their own? So where is your org on that spectrum? So I'm going to start the survey now, and you'll be able to see how everybody else is answering in real time. So I'll go ahead and kick off that survey right now. So I think you should be able to fill this out. So how much is your company invested in self-service data at your organization? Perhaps you don't plan to at all. Perhaps you have some plans in place. Maybe you have started an effort. Maybe you've made some progress on that effort, or maybe you're already there. And you already have a very strong self-service atmosphere at your company. So I'd love to know where you guys are on that spectrum. So let this go for a few more seconds. All right, I'll close the poll. Looks like 2 folks have kicked off an effort or have started something, and 1 is reasonably far along in the process. Now, a big surprise, nobody has 0 plans to start a self-service effort. And strong self-service, is a pretty rare thing. So I think these results probably are what a lot of us would expect to see across the industry at large. So thank you for filling that out. So back to our data platform challenge. So what does that product team want? They want a lot of speed, right? They want to be able to evolve their data model, change their schemas. They want to constantly be able to adapt the pipelines that feed their analytics products. They're trying to iterate quickly, right? And build a competitive product that we can sell in the marketplace. So why did I drop a sports car here? Because that indicates sort of how they want to work with data. They want it to be very flexible. They don't want handcuffs. On the other hand, though, we've got all these other teams that are consuming their data out of the platform. And what do they want? Well, they want stability. They want it to be relatively predictable. They want it to be comfortable, because if I'm, on the financial analytics team and I go write some, dashboard, or if I'm pulling data out of product information from the platform, I would like to expect that it's not going to suddenly change under my feet, right, and break my analytics dashboard or break my report that I'm generating for my team. I may not be close to the product team. I may not even know the individuals on that team. And so I would like to have some expectations in place that data is not constantly changing, so that I can get my work done, right? So what does this often do is we've got these producers and we've got these consumers, and sometimes the producers want to go fast and the consumers want things to be stable. So that really puts the data platform team often in a crunch, right? They throw their hands up a lot of the time. I used to be in this position where it was like, hey, the data that I'm getting loaded into the platform, I can't control what they're emitting or when it's changing, but I do have to deliver it to these consumers on the other hand, and so they're getting upset at me because the data is changing under their feet and it's breaking things. And that can in turn also cause a breakage in the actual product that the product team is delivering to the market. And that's really when things are the worst, right? Because now we might have material loss to our revenue. We might have reputational risk. We might have a machine learning model, for example, doing something bad in our user-facing application, and our customers are actually now impacted by that data reliability problem, right? So this is the challenge that I think a lot of teams are dealing with today is we have all this variety of stakeholders. We have these fairly important use cases that we're using data for these days to actually drive revenue. How do we find this balance between giving our engineering teams, our product teams, and our services teams the velocity that they need to be competitive in the marketplace, but how do we not have the data be so unreliable that we're not able to use it throughout the business? So enter data reliability engineering. Let's talk about what that is and why I think that helps. So if we look at this, I talked about this trade-off. We can go faster. That's often at the cost of reliability, right? We can, have no code review process. We can have no testing process. Data engineers can just change pipelines whenever they want. Data producers can change their schemas whenever they want. No controls at all, right? Total Wild West. So we could go super fast and we can evolve things quickly in our data model, but we're probably going to break things a lot, right? On the other hand, we can put a lot of heavy process and controls in place, and we can really lock things down, have very strict governance. And what that'll do is it'll get us a high level of reliability because we have these controls in place, but that obviously slows things down as well. So what do we wind up with is this efficient frontier where we can locate ourselves along that spectrum. And for some organizations, it's going to make a lot of sense to trade off reliability for velocity because they want to move quickly, and it's okay if things are a little less reliable. And then for other organizations, healthcare is one thing that comes to mind for me immediately, and I'm sure there's a lot of other industries or applications where it's way more important to have a highly reliable data stack than it is necessarily to be able to move quickly. So locating oneself on this frontier is something that the organization has to decide. But how do we potentially move that frontier? How do we strike that balance? Well, in software engineering, we have site reliability engineering, right? So this is a function that started maybe 15 years ago or so at Google. And this is a quote from VP Eng at Google, and a person who's frequently attributed to the early days of site reliability engineering as a practice. But the way that Ben describes site reliability engineering is it's what happens when you ask a software engineer to design your operations team. So if we're going to operate a whole bunch of servers, those servers are going to run our software. We need a process in place for, when we ship changes to our software, how do we make sure that doesn't take things down? How do we make sure that we're not running out of disk or memory space or CPU? So how do we allow our software engineers to build and ship things quickly without causing an operational nightmare where we're constantly taking down our software and impacting our paying customers? And the way that we did that in site reliability engineering was with tools and processes, right? So service level agreements, SLAs, with monitoring and observability. So Datadog, Sentry, PagerDuty, there's this whole crop of tools that came about over the last decade plus to help these software engineering teams build quickly, but also make sure that our software is reliable. And if we didn't have that, we might not be on this call right now because we might have been disconnected from it already. But we just sort of expect that most of our software these days is highly reliable and that it also evolves rapidly. So what that meant is that with the introduction of techniques in site reliability engineering, software engineering teams were able to extend that curve, right? They were able to push it out. So now we do still need to locate ourselves along that curve, but we can extend the curve outwards in space and say, okay, at the same level of velocity, I can have higher reliability if I wish. Or for a given reliability level, I can still move faster because I have processes and I have tools in place to help me do that. So we can move our efficient frontier outward in space. And so we do still have to make a trade-off, but that trade-off is more easy for us to stomach, or we're able to get more without giving up the other because of that leverage that we get from tools and process. So I skipped over a survey here. My second survey today is at your organization. Where do you feel you are on that frontier, or where is the right place for your company? Is it way along the velocity spectrum and it's okay to pretty much give up any sense of reliability? Are you way on the reliability side and it's just super critical that nothing breaks and you're willing to trade a lot of velocity for that, somewhere in between? So I'll kick that survey off now and take a few seconds to start that poll. All right, and I'll close the poll. Looks like everybody fell in the same place. It's super interesting. So everybody said, I'm not going to go so far down the reliability path that we can't make progress on our data platform, but reliability is sort of where we want to focus. I think a lot of teams probably find themselves in that place, right? If things break, then they're not going to be trusted by the organization. You're not going to be able to put those data products in front of your customers. You're not going to be able to leverage them in sort of the highest impact places. So I'm kind of not surprised by this answer, but okay. So how would we apply this to our data teams then? The site reliability engineering concept that allows us to push out that efficient frontier, right? Well, this is where I think data reliability engineering comes in. So the previous quote was from Ben at Google 15 years ago. This quote's from me right now. But data reliability engineering is what happens when you ask a site reliability engineer, perhaps who already has experience in DevOps and site reliability engineering, to design your data engineering team. So in theory, this is what would happen if someone were to say, hey, let's airlift these practices that already are sort of proven at scale in software engineering, and let's just drop them over here to data engineers. Now, obviously, that requires some translation or massaging, but in principle, the same idea is there, right? We want to move our frontier out. We want to be able to say, hey, for maintaining this level of reliability that's critical at my organization, I don't want to have to trade off so much velocity from my team. to be able to protect that. The way that we do that is with the exact same set of practices that we have in site reliability engineering. So there are 7 that are sort of famous or critical from the Google SRE handbook. Number 1, embracing risk. So just saying like, hey, we are going to have failures. It's going to happen. What's important is that we design and plan for those, and that we have processes and tools in place to help us deal with problems when they occur. But we can't stick our head in the sand and say, hey, the data's never going to break. Or how do we get to perfect reliability? It's just not, it's not a thing that can be done, right? Number 2, setting standards. So this is having contracts and agreements and quantified definitions in place. This is really, I think, where SLAs come in. The whole industry could use more of them in my mind, but how do we get a quantified definition of this is what data reliability means in this application to the business? And we have a clear definition around that. And we also have a response process. So when that SLA is violated and we know that customers are going to be impacted, we already have a plan in place. We're not making it up as we go. Number 3, reducing toil. So this is just relying on machines. It's relying on repeatable patterns so that we don't have human beings constantly doing every single button click that's required to operate our data infrastructure. So how do we make things scalable, repeatable? How do we use common patterns everywhere, standards, et cetera? Monitor everything is number 4. This is obviously where my company comes in, and data observability as a space in general. We need to know how the system is behaving at all times if we're going to be able to protect these standards and respond to things and protect our users and business from risk. Number 5, automation. One engineer should be able to get a lot done. They should not have to, sort of repeatedly do manual work. It's pretty clear. Controlling releases. So again, this would be version control. This would be code review. And this would be testing. So this is just making sure that the changes that we make within our system are understood before we put them out. And then maintaining simplicity. So if we have a lot of complexity, that also introduces a lot of risk, right? There's more moving pieces in our data platform that can go wrong. So these are sort of the 7 core principles. Each of these, involves some amount of people process. Some of these can be assisted with tools. Again, monitor everything is kind of the category that we find ourselves in here at Bigeye, is helping teams get to the level of instrumentation and visibility they need across their entire data platform so that they can understand what's happening inside kind of in real time. And then where does that fit? And again, I describe data observability as part of data reliability engineering. So here's how I like to visualize that relationship. Data observability, in my mind, is the precursor to being able to do a lot of the other work in data reliability engineering that lets us push that curve out, right? And then in turn, there's a bunch of other work that has to happen in data operations, which isn't the topic of today's talk, but in my mind, data observability is that stepping stone towards being able to implement data reliability engineering as a process. So why now? Just to wrap it up, like, why are these things critical today? Why weren't they yesterday, perhaps? In my mind, it's for 3 big reasons. One is the impact of use cases for data teams is going up over time. We're putting data directly in the line of fire in our products and services. There isn't a human being in the loop anymore as much as there used to be. And what that means is that when things go wrong, there is direct impact to the business on the line in a way today that wasn't the case 5 years ago and was not the case 10 years ago. Obviously, data has always been important in the enterprise, but I think that progressively we're getting to a state where there's sort of like constant connection between the analytics data and actual revenue or customers. Number 2, diversity of stakeholders. So I talked about this at the beginning. We've just got more folks at the enterprise that want data. They want to be able to consume it. They want to be able to leverage it in their part of the business and what they do. And when we do that, it means there's more eyeballs on the data. There's more requirements placed on the data. So what we're asking of our data platform team is harder to meet. And then number 3, complexity of our pipelines. There is more data. We know this. It's coming from more sources. It's being used and transformed and combined in more ways. And as the complexity of the pipelines that we use go up, there's more things, again, that can break and cause problems and introduce risk to the company. So as all 3 of these trends kind of go up at the same time, that confluence, in my mind, is really what's driving the need for data reliability engineering at the enterprise today. And so with data reliability engineering, and as we implement that, we start to move from a customer and executive method of discovering problems. We now move to automated monitoring systems. Instead of having conversations or arguments around, what problems we have or what data quality means, we move to a system of service level indicators and service level objectives. So we start to get quantified about what does quality mean. Prioritization moves to an SLA system. So which SLAs, do we need the highest compliance with? And our velocity and reliability go from, perhaps we have great velocity but bad reliability. Let's get to good and good, right? So responded the same way on the survey, which is reliability is important. I want velocity, but I'm not going to give up reliability to get there necessarily. So how do we keep the reliability level where it needs to be and then get as much velocity as possible? Subject to that constraint. And then, of course, toil. We don't want our data team spending all their time fighting fires and doing sort of menial tasks. So with these sort of repeatable processes and better tools for doing reliability in our data stack, can we get to the point where they're spending 80% of their time doing engineering and maybe only 20% of it doing these sort of manual firefighting tasks? And so to summarize those, higher impact, more stakeholders, more complexities driving the need right now. I think that velocity reliability frontier is the thing that many organizations face, and locating themselves on that frontier. But we could push that frontier out with tools and practices borrowed from site reliability engineering. And in my mind, data observability is the first step down that path, because we need to know the state of our system and what's going on inside so that we can prioritize our efforts and so that we can start to install these practices to keep our pipelines reliable. So that wraps it for my talk today. I think we have about 10 minutes left in the session. So I'm going to stop my screen share. And if anyone has any questions for me, I'd be happy to take those now. Thanks, Wayne. Yeah, I wish I could have made the panel today. So yeah, that last minute conflict, unfortunately, wasn't anticipated. So, but I'm sure it was a great session. Wish I could have been there. Any other questions today? If not, great. I hope you guys enjoy the rest of today's event, and I hope to hear from some of you if you're implementing data reliability engineering or observability at your orgs. I would love to talk to you, hear how you're doing that, and possibly show you Bigeye if you want to see how we approach data observability. Thanks for listening today.